Rabbit Hole. I'm Joe Slick, your host, and I have with me Canuck and Mr. Clemmer, or the Snowplow King. And we're going to talk about some interesting things, a little bit interior now, the Intermountain Seismic Zone and its implications and the effects it has on different areas. And this will be a little bit of a series. I think we're going to build on top of this. We're going to try and wet your whistle for what's going on and why it's important. And then we're going to kind of come out on the next one and build back into why and how these things are working in these areas and why there's quakes happening on the interior part of the United States, specifically Utah, Idaho, Montana, and Arizona, Nevada, and New Mexico, and Texas. So, and even Colorado and Wyoming. So, it's the whole kit and caboodle, and we're going to talk about a lot of those things. And then we'll probably end up going east into the most people are terrified of it, but New Madrid and the other seismic zones that are up in that area. But that'll be down the road. But we're going to build. I think build a consensus of uh, different thoughts and try to synthesize it. I can't even say that word. Synthesize it, break it down, and then make it palatable for you over the next few series here. So this is not just going to be a wham bam, thank you, ma'am, all done with that, but we're going to kind of stay in this area of Idaho, Utah, Nevada, Eastern California, Arizona, uh, New Mexico, because there's a lot going on within this last 100 million years. I mean, a rash of super volcanoes, a rash of volcanoes happening all throughout the United States, the, the continent where the United States just happens to be. And because it doesn't care about state boundaries, of course, none of this does. And so we're going to deal with a lot of that as we get into this series here. We've done the West Coast. We're tied in with what Professor Nick's doing up there in Central Washington University, and watching his shows and learning from what he's got to say. And ours should kind of dovetail with it, coming at a little easternmore view of where he's at. And he'll be talking about all the stuff accreting and creating the volcanoes, the Cascades. And we're going to be on the other side going, this is what's pushing up against that. And that's how we're gonna present this. But tonight we're gonna start with Canuck and explaining, revealing the deep cause of the Intermountain Seismic Belt. And so, without further ado, good evening, Canuck and Luke. Welcome.
Yo.
And let's start what you got there, Canuck.
Yeah,
You got
so we're
your
just going to
first thing here.
talk about this new study that came out, and I'm going to refer to the maps because that makes it easier to understand rather than just reading all the
Mhm.
words. Now, this thing here that we're looking at right now is the simplified short version of it. It's not the whole study. We'd be here for hours if we did it, but this little article research thing they did here is like the summary of what they're talking about. So I'm going to read the first part of it, and then I'm going to explain the maps after, because it gives like background on where the Intermountain Seismic Belt came from or whatever. So I'm just going to read the first part of this. The lithosphere, Earth's outmost layer, is a complex and intricate
Easier for you to say.
comprising the crust and a portion of the uppermost mantle. This layer is composed of several tectonic plates constantly moving on Earth's surface. According to the theory of plate tectonics, lithospheric deformation primarily occurs in the narrow regions near the active plate boundaries due to the relative motion between the adjacent plates. Besides, the plate's interior is considered rigid and free from deformation. However, it has long been observed that earthquakes can occur in areas hundreds to thousands of kilometers away from the active plate boundaries, particularly on continents. Recent advancements in geodesy, such as the use of global positioning (GPS), have further substantiated active intraplate deformation in many regions globally. The Western United States, WUS is the abbreviation they use in this study, is one of the best examples of enduring intraplate deformation. Currently, the Western United States displays a spatially broad and complex deformation pattern with frequent intercontinental earthquakes and widely distributed crustal motion relative to the stable North American plate. The driving mechanism for the Western United States intraplate deformation is still poorly understood, particularly for the remarkable north-south trending Intermountain Seismic Belt. The ISB, which stretches from the southern Colorado Plateau to the northern Rocky Mountains, has intense seismicity and lies thousands of kilometers away from the active plate boundaries with an enigmatic origin. In addition, Western United States intracontinental earthquakes frequently occur in densely populated regions, causing catastrophic impacts on people, infrastructure, and the natural environment. Therefore, understanding the driving mechanism for Western United States intraplate deformation is not just a scientific pursuit of understanding Earth's tectonics, but a crucial step toward better preparing people for future earthquake threats. So now these first two maps that are in there, and they're basically, the first one there has all those dots are quakes from 1980 to 2020. So all those red dots it has on the map, so it's kind of showing it how it goes around. Well, the Intermountain Seismic Belt is the stuff there on the east, but it's also showing like the big ones in California and along the Sierra Nevadas and basically Walker Lane, if you really want to simplify it. That's what it's showing in that first map. And then the second one is basically where they have the red lines. That's basically the Intermountain Seismic Belt. So if you actually read all the new stuff that's on it, they say it's actually should be considered like one big thing. It's like 1,300 to 1,400 kilometers long, and it goes all the way from northwest Montana all the way down to northwest Arizona. And like when I started looking into this before, I said, well, that's an interesting shape how it is there. It kind of looks like the arrow shape, which is like the first terrains. If you go all the way back to the Karen Siglock stuff, like the first terrains that smashed in North America or Western North America, it's like the same angle. So I thought that was interesting from that one. And so on these maps, the first one there has like it has Snake River Plain marked. It has the Great Valley.
Am I on the right map there for you, bud?
Yeah. There's two right at the top. The first one is the one with all the quakes on it, but it has like Basin and Range marked, Great Valley, Snake River Plain, and Pacific.
Oh, okay. It's a similar one.
Yeah. And then it has Colorado Plateau, the Rocky Mountains, and whatever.
Yeah, it has the one I'm looking at. Yeah.
Yeah. WP. I forget what the name of the plateau is, but it's another plateau that's there. And then it has the Rio Grande Rift on it too. So it's showing like the entire west coast of the U.S. from north to south on that map.
Yeah, I don't know what we're looking at, but
well, there's two maps right there at the top.
Yeah, I see them.
Yeah,
I'm sharing them for you. then yeah, they're talking about all the GPS and how they've traced North America moving. That's
those are the
that's why
ones
you
that
brought
are
this
down
up.
farther.
Yeah.
Yeah, because there's 5 maps. I only talked about the first 2.
Sure. Only first 2, yeah.
Yeah. Now I'm going to go into this next section. I'm not going to go too
Okay.
far into it because it gets super complicated. But
Yeah.
yeah, the driving mechanism for Western United States intraplate deformation has been debated for decades. The proposed driving forces broadly fall into 3 categories. The long-range plate boundary forces due to the interaction between the Pacific plate and the North American plate and the subduction of the Juan de Fuca plate. Number 2, the lithospheric body forces arising from the homogeneous lithospheric density, structure, and surface topography. And 3, the viscous drag exerted by the underlying mantle flow. So in all these studies,
So what do each one of those mean?
well, the first one, they're saying it has something to do with the interaction between the North American plate boundary and Juan de Fuca. But the problem is there's a lot more plates that interacted with it than that.
All right. Well, just what they're saying.
Yeah.
That's all I want to say. North
Yeah,
America and the
this is the
JF
angle they come at it.
angle,
right?
and that's what they said. That's the driving force. That's driving force number 1. What's the second one?
Second one, I think what they're saying there, the lithospheric body forces arising from the inhomogeneous lithospheric density structure. That's how
The upwelling.
the thickness of the plates. Because see, it's thinner in some spots and then it's thicker in others. And
Right. The
and
homogeneous would be where it's from, and then the thickening of the plate. The lithospheric body, that's what's down below, what's gone down into the lithosphere, and that's it. As it crunches up against things, it's building up and making the mountains. And I think that's what you're saying. Am I right?
Yeah, and then the other part they're talking about the drag exerted by the third one, underlying mantle flow. So they're saying the mantle flow is moving around and running into all this stuff, and that's what's either lifting things up or thinning them out, like in a basin.
Okay.
That's basically what it is. So they're using these big words, like what
Yeah, $6 words, definitely.
Yeah. Many studies have been devoted to understanding the cause of Western United States intracontinental deformation. Still more consensus has yet to be reached, mainly due to inconsistent assumptions.
And deformation is something that was flat that's not flat anymore. It's been deformed.
Yeah. So it's changed from what its original thing was.
Status was, yeah.
Yeah. Now I'm not going to go into this next part because it's getting.
Whoa.
Yeah, because it's talking about topography, and then it's the lithosphere, asthenosphere boundary, and then they shorten it to lab because
that
they
thing
don't
has a virus. That one had a virus.
Which one?
That last picture I put up there for you.
Oh,
it popped up as a virus.
In the map. There's a virus
in the map.
That's nice.
Yeah. I said, "Oh, thank you.
Yeah.
Thank you for telling me."
Yeah, and then it talks about in this how the convecting mantle was only allowed to exert horizontal shear along a flat lithosphere. But see, the problem is the lithosphere isn't flat, right? Because in some places it's thicker and sticks down farther, and that's what they're getting into as they go down into this, because they say seismological studies have revealed that the lithosphere asthenosphere boundary depth has significant lateral variations on both global and regional scales. And then it talks about it can be as the crust can be as deep as 250 kilometers in some places, and then other places is right thin. So it's going to affect how the mantle convection works.
All right, what's mantle convection?
Well, that's all how the mantle is moving up or down, right? And where there's hot spots. And like, I think what they're saying is there's different currents in the mantle, but
The mantle being in the land itself, in the crust, or underneath?
no,
In the
underneath.
lithosphere.
But
There are currents
underneath,
in the lithosphere, is what you're saying.
yeah, I think that's what they're saying. It's just
Okay.
and like if the crust is thicker in one spot and thinner in the other, it's going to move differently, right?
Yeah, it's like we have mountains, and the air moves around the mountains, right?
Yeah.
And we got valleys, and it moves down in the valleys and moves around the mountains. It rarely goes up and over the mountains because it needs the least way of resistance, right?
Yeah.
So if you flip the mountains upside down, and if you flip the whole land upside down and put what's out here down there, it'll look the same. It'll be just mountainous with valleys and the like. And
then
the currents ride between those.
The three other maps there where they're showing how they think it's moving with the GPS. And then they show the colors where it's red is like hot and blue is colder. And then they can see where it's yellow or whatever. So it's hotter there and how the stuff is moving. And it's like the quakes are around the edges. That's what they're trying to show there. Looks like the majority of the quakes
in the yellow spots, huh?
Yeah. Are
in
around the edges.
In the depth, yeah.
Yeah. And see, it's kind of like the magnetic stuff that they're using now too.
Let me see if I can share this screen here.
Like what Megan Anderson said there about the stuff in Washington, because they can see stuff that's colder and where it's warmer.
Much like what you see here on this image.
Yeah, because all this stuff is all related that they're doing.
So
it's just
tomography
this
looking
is now the whole western part, right? So it's crazy.
So what? There's three different maps here. The one on the left is telling us what?
I think that one's
predicted horizontal mantle flow at 150 kilometers depth, relative to the stable North American plate, and observed azimuthal. So I never heard of that word before.
Yeah.
Azimuthal.
So that's like how they think the mantle is moving. At whatever.
Yellow bars showed a fast propagating direction of shear waves. At 100 kilometers overlying the lab depth. The colored contours indicate upper surface of the Juan de Fuca slab at different depths. B is earthquake epicenters from 1980 to 2020. Overlying predicted crustal deformation rate. And C is predicted in magenta arrows and observed black surface motion overlying the magnitude of their residuals. Okay. So in that first image, it has some, you can see the discoloration of the Juan de Fuca. I think that's what they're saying. The plate, and at different depths. And it has to do with some shearing, I think, what's going on. And at 100 and what? Very deep. At 150 kilometers depth relative to the stable North America. Horizontal mantle flows. So there's horizontal mantle flows.
Well, to me, that would make sense because that's why it's rotating, right? Which is
but it's the arrows are pointed the opposite direction that we're talking about.
Yeah, I know, but it would be like how a tornado works. Same idea, I think, because it's spinning around.
And the middle one shows you all the different earthquake epicenters since 1980. And I don't know what the ISB is, Intermountain Seismic Belt.
Yeah. So that's, they have it marked on there in the red lines. from the other
So
mountain.
that's the East Coast is the ISB.
No, well, the ISB is all those that mountain range from, well, includes the Rockies, but Wasatch and everything else.
Right. Okay. Then why the ISB is? Oh, well, what's this thing in here in the middle here? I don't know how to read that.
What the? Well, the blue stuff
on number B, on figure 2, number B.
Yeah, the blue stuff would be that's down at the bottom. That would be the Colorado Plateau, the W one, whatever the W one is named, plateau, and then coming up into the Rockies. Because like the ISB is the western edge of that whole mountain range that's going from.
So basically, this article is talking about the flow of magma, what we would call magma, the flow of whatever's going on in the lithosphere. It's actually like currents.
Yeah,
and that's what this article is kind of saying.
And that's why you get these rotating blocks. I think that's
Right.
what it's doing.
Yeah, that's
if you
kind of
look
what.
at the, if you look at the third one, that's what it looks like it's doing to me.
Yeah, I mean, you can see that's the GPS in C. That's the current GPS. However, we see other things happening in California that's making it go due south, and the GPS does not convey that at all. And I don't know how.
Some people say the Mojave's rotating too, so it just depends on who you're talking about.
It could be the Mojave. Yeah, because the Walker Lane is a path that goes south. I mean, I don't know. It's like if you made all the, I don't know how true that would be, but how I understand it, and with watching the earthquakes and the movement, you see where Ridgecrest, east of Ridgecrest or west of Ridgecrest went due south. South and southwest as it went around the corner on the Garlock. And nothing's going north. This the left side, or the ocean side, so to speak. It just moved faster than the other side. So when it split toward Garlock, and the actual city kind of twisted a little bit. I think there's a pretty good offset, 15 feet offset, because of the slippage. And I think that's pretty interesting. But I don't know. I think it's some of these articles are pretty technical, and maybe I get lost in them a little bit.
Yeah. At the end of this one, it says, beyond the western United States, many other regions also exhibit intense interplate deformation, and most of them are at high risk of earthquake hazards, such as Mediterranean, East Asia, and the Tibet Plateau.
Right.
So basically, there's a bunch of other places that are doing crazy stuff too.
Right. So we can conclude then, earthquakes aren't going to happen only on the plate margins. They're going to happen interiorly. So the New Madrid was not a fluke. We see intercontinental quakes in China all the time. We see them along the Afghan border and all the stands. We see them happen all the time in the border with China, but there's no continental boundary. There's deformation that happens up there. Lake Baikal, generally when we see something happen in the Sea of Okhotsk, we can pretty much guarantee to see some movement up there in Lake Baikal. However, It seems to have slowed lately.
Drastically.
It's like I haven't seen an earthquake in Lake Baikal probably only one last year that I remember, but the year before was several.
Yep.
It's like, hey, what's going on? Is there a cycle that works? Kind of like, found one thread. All right. Caffeinated installer. Okay. Quarantine that son of a bitch. Found a malware.
Well, that's interesting. Consider it's in like an official
Oh yeah. Okay, they got it.
science site, because that's where that's from.
Yep.
But
So,
funny.
and my system found it. So,
Yeah.
and I was wondering why it was taking so long to download. I'm like, hey, what are you doing? And then they got quarantined. But yeah, that's interesting. So let's move on to your next slide.
Yeah,
Unless
the
you- are
next
you
one
done?
is just the list of earthquakes in Utah. So I'm just gonna go over those first, because we're gonna be talking about the ones in Utah mainly, and not all of them, but
Alrighty then.
a bunch of the main ones we're gonna look up later. So this list here is only from 1900. It starts. So they
All right.
list
So
them
what do
all.
you want to talk about on this one?
Well, I'm just going to say that the main ones we're going to focus on is the 1934 one,
Okay.
and the 92 and the 2021.
The
When we
Great
get
Salt
started.
Lake, just north of the lake in 1934, had a 6.6. And what other one?
92, St.
Okay.
George,
St. George had a
which is
5.8,
hurricane fault. Well,
which is
by
on the
hurricane
hurricane
fault.
fault. Yeah.
Yeah. And it was right after the Lander stuff. And then
Right. We're gonna revisit this this list here, so don't worry about.
Yeah.
Oh,
in
God,
2020, Salt Lake City, or the Magna Quake, because they call it the Magna Quake too, which was the one that happened in early 2020, not long after Ridgecrest. Some of them we kind of know about already, but we're not going to do every one of these. But we'll do a few just to see how they were working.
All right.
And now we're going to go to the next slide, because the University of Utah actually has a thing where they keep track of all the Intermountain Seismic Belt historical earthquakes. So when you see that one, you see that they have a because the whole Intermountain Seismic Belt thing started in Utah.
Right.
The old geologist there, Gilbert. So
Yeah, the Intermountain Seismic Belt Historical Project in the USGS, awarded in whatever, is a compilation of newspaper articles, photographs, personal accounts, and scientific detail of 48 historical earthquakes along the Intermountain Seismic Belt, or ISB, within Montana, Wyoming, Idaho, magnitude 5.5 and larger, and Utah, magnitude 5.0 and larger. Since the origin of the project was completed in 97, some of the magnitudes of the earthquakes have been updated with further work of the modern technique, and modern magnitudes may not match all the magnitudes listed in this project. The effort is intended to personalize earthquakes risk to current residents in the ISB by presenting evidence of real impact of people and places from the ISB earthquakes. The purpose of this promote better understanding of earthquake threat in the region to motivate individuals to prepare for earthquakes. Yeah, that's exactly what JSL is all about. That's why we study these things.
now, so their records go way back into the 1800s on this list. So they show a bunch of them here, but I wanted to make it simpler, so I went to where they organize it by date. So that's the next link.
The Wasatch?
Well, they organize it by date, so like 1800s up till
Okay, I didn't get that article.
Oh,
But that's a video here.
it should have showed up as earthquake list date 2 PDF.
Okay, I'll look it up. Hold on a second.
Well, it's when you click on the right below all that the list of quakes they have there, because I wanted in chronological order. So I
That's
clicked
fine.
by date underneath, and it gave me the.
I know you did. I must have missed one. Remember, I'm dyslexic.
Yeah.
Okay. Dun, 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 dun. List of till 2020. No. That's at the end. One,
Yeah,
two.
the list in here only goes to 94, but it shows all the ones going back to 1870.
Yeah, EQ to PTF. Yeah. All right, I got it, brother. And I downloaded this already, but let me zoom it in for people to share this tab. All right. So, what do you want to talk about, buddy?
Wow, it's just interesting because if you look at what it's doing, it's like alternating all over, like in the Intermountain Seismic Belt.
All right, show me what you mean.
Well, the first one's 1876. It's a Utah quake, 5.0.
Mm-hmm.
Then in 1884, it's an Idaho one.
That was a 6.3, huh?
Yeah. In 1887, it was a Utah one. That's the same year as the Sonora quake. 1891, St. George got hit, which I didn't know about that one. So that's hurricane fault. 1894 is back in Ogden, so that's Wasatch. 1900 Eureka, I don't know exactly where that is, but somewhere's in Utah. Some of them, they don't have the exact name, like a place. 1901, Southern Utah, Pine Valley. Then they got 1905, Idaho. So Idaho went off. Idaho went off the year before the big San Francisco quake, and then Utah went off.
Yeah, San Francisco was in the early part of the year, right?
Yeah, April 1906.
All right, so this Idaho was at November 11th of 1905.
Yeah, so that would have been
That's still within a year.
Yeah, a few months before. 1906, and then Milford, Utah, and then I saw Hansel Valley again, because you already know about the 1934 one. Well, it did a 6+ back in 1909. Like when I started looking at this, because I didn't have like all these dates of all the other ones all in one thing, I could kind of see what it was doing. See, and then there was a 5.5. So there was 2 close together in Utah in 1910. And then see 1914, Ogden, Utah, which is Ogden's on one of the segments of Wasatch, 5.5. So that was around the same time all the stuff started happening with Lassen and all that in Nevada. And see 1915 was Provo, Utah, 5.0. So I started looking down and I started associating all these dates with the other dates of the quakes I know about. Like 1925 was the Santa Barbara quake. Well, same year, Montana had a.
Well, often we've discussed. Share this tab instead. All right, so I'm sharing a tab for you, and I think this is a little easier for our listeners to grapple with. You'll see this is the Wasatch Fault, okay, and along these fault is where all these quakes are happening, and I'm not sure with this image if it's helpful to say where each one happened, but I don't even know what this is even telling me when I looked up Wasatch. During the past 10,000 years, major earthquakes of magnitude 7 or greater occur about every 900 to 1,300 years along the one of the 5 central segments of the Wasatch
Yeah,
Fault.
that's been updated now because this one we're looking at is from 94.
Right.
So we're going to read the newest stuff next, and they found out.
However, the average time between the earthquakes along the entirety of the central segments is about 300 years. The segments that underline Salt Lake City produce major earthquakes approximately 1,200 to 1,300 years. The Weber, Provo, and Nephi segments each produce one about every 200 to 700 years. And the Brigham City fault segments has not produced a major fault in the last 2,800 years. So in looking at this image, you see if I can save it and then open it up for you. Come on. Okay, Wasatch, save this. Because I was getting kind of lost, and I'm sure other people were too, with what we were saying.
It's going to make more sense when we play the 2 short videos.
Sure. What the hell is going on? There we go. So let me.
Well, just kind of being Captain Obvious here, but that 1994 paper that you're looking at is 30 plus years old now.
Well, the paper we were talking about earlier was from 2024, but this thing here, this list of quakes, the last time they updated it in this thing that they're doing at the University of Utah was 1994.
Right.
So that's the list there only goes to 94, so it doesn't have the newest quakes on it.
Statistically, the Wasatch Fault is overdue for another major earthquake. Experts have given it a 57% probability of a 6.0 or greater in the next 50 years. However, statistical frequency does not necessarily imply periodic behavior, though it can serve as a good indicator. Liquefaction due to the strong earthquake is a particular concern in a lot of populated areas. So that'll be something that if you live along the Wasatch, you may want to be aware of that.
Yeah.
The Wasatch Fault is an active fault located primarily on the western edge of the Wasatch Mountains. The U.S. states of Utah, Idaho the fault is about 240 kilometers long, stretching from southern Idaho through the northern Utah before terminating in central Utah near the town of Fayette. The fault is made up of 10 segments, 5 of which are considered active. On average, segments are only 25 miles long. Each can be independently produce earthquakes as powerful as a 7.5. Wow.
That's nothing to see with that.
The 5 active faults are Brigham City, Weber, Salt Lake City, Provo, and Nephi. So those are the, you can see where Ogden is and Salt Lake City, Provo is right on the image that you have on your screen. So that's telling, man. When you get an interior quake, not on the plate boundary, but an interior, and you get a 7.5, that's pretty serious. That's kind of the same Nephi. Yeah. That's kind of serious because that's kind of like the New Madrid. It's in the middle. And you get a 7.5, and it's not necessarily related to the park. I call it the park because I don't want to say the word. Because once you say the word, boy, man, people just go nuts. And look at Professor Nick. He's got to deal with that all the time. So where do you want to go now, bud?
I want to go to the 2 YouTube videos because I tried to find ones that were short and had a lot of good information in it and basically explained it.
Right.
So those are the 2 best ones I could find.
Yeah, Utah Geology Survey. We should be able to do this because it's for teaching purposes.
Yeah.
And we'll share this instead.
Yeah, they're both from the Utah Geological Survey.
Utah straddles the boundary between the actively extending Basin and Range Province to the west and the relatively more stable Rocky Mountains and Colorado Plateau to the east. This boundary coincides with an area of focused seismic activity called the Intermountain Seismic Belt. Since pioneer settlement in 1847, Utah has experienced 16 damaging earthquakes greater than magnitude 5.5. However, geological studies of Utah's active faults, of which there are more than 200 statewide, indicate a long history of repeated large earthquakes of magnitude 6.5 and greater prior to settlement. For example, about 300 years ago, a major earthquake shook the southern Wasatch Front near the present town of Payson. Based on geological studies, this earthquake occurred on the Wasatch Fault, the longest and most active fault in Utah. Although no large earthquakes have ruptured the Wasatch Fault historically, abundant geologic evidence shows that the fault has generated more than 24 magnitude 6.5 to 7.5 earthquakes in the recent geological past. Because of the close proximity of the Wasatch Fault to the majority of Utah's population, as well as relatively high rates of historical seismicity in the region, communities along the Wasatch Front are exposed to the greatest earthquake risk of the entire Intermountain West region. The Wasatch Fault is a normal fault that extends about 240 miles from southern Idaho to central Utah and is largely responsible for the dramatic topography of the Wasatch Range. Normal faults result in vertical movement, with the valley side of the fault dropping down relative to the mountainside. During a single large earthquake on the Wasatch Fault, fault movement at the ground surface can create a break or scarp about 5 to 10 feet high and extending along the base of the range for as much as 25 to 40 miles. Over millions of years, repeated individual fault movements have combined to form the prominent vertical relief of the Wasatch Front. Geologic studies show that the Wasatch Fault is composed of 10 individual fault segments, each of which is capable of generating a large magnitude earthquake. For the central, most active part of the fault, which includes 5 individual segments between Nephi and Brigham City, a large earthquake has ruptured the ground on average about every 300 years. This pattern of earthquakes in the geologically recent past is a realistic guide to what we can expect in the future. Thus, geologic studies help us understand the earthquake potential of the Wasatch and other faults, and ultimately help us take steps to reduce Utah's seismic risk. At this site, the Utah Geological Survey and the U.S. Geological Survey collaborated in a detailed study of the Nephi segment of the Wasatch Fault. By excavating a trench across the trace of the fault, geologists are able to expose and study sediments near the fault and reconstruct the history of past fault movements. Each fault movement that breaks the ground surface occurred during a large earthquake. This trench, at the North Creek side on the Nephi segment, exposed layers of sediment in a steep, west-facing hill slope formed by multiple recent movements on the fault. The North Creek exposure revealed evidence of 4 large earthquakes in stream and debris flow sediments estimated to be about 5,000 years old. In the trench, geologists carefully cleaned the walls, set up a 1 meter or about 3 foot grid using carefully surveyed string lines, and systematically photographed each square in the grid. The individual photos are then merged into a composite photograph of the entire trench wall. Geologists use colored flagging to mark significant geologic features, including faults, distinct sediment layers, and locations for soil samples used to date the deposits. Electronic instruments are used to accurately measure and map each layer and fault, which yields an accurate and complete map of the trench exposure. After compiling a detailed map of the site and trench walls, the geologists measure the amount of fault movement that occurred in each prehistoric earthquake and submit samples of various sediment layers for dating. 2 dating methods are typically used: radiocarbon dating of organic sediment and charcoal, and luminescence dating of fine-grained sand. Using the information on when the different sediment layers were deposited and whether they are displaced by faulting, geologists can interpret a history of when past large earthquakes occurred. This information helps us understand how frequently large earthquakes happen on the fault and is used to make earthquake hazard assessments for the Wasatch Front region. This trench investigation took about 2 weeks to complete in the field and involved scientists from the Utah Geological Survey and the U.S. Geological Survey. The project was partially funded by a grant from the National Earthquake Hazards Reduction Program. The results of this study will be released in a written report by the Utah Geological Survey. You can find reports of similar fault studies at geology.utah.gov.
All right. So what do you want to go from here?
The next YouTube video does a flyover of each segment so you can understand more what
All
they're
right.
talking
That's what I'm looking for. And there was an image. I'm looking for it. Right here, I think. There we go.
Yeah, the next video goes into more detail so you can see what they're talking about.
Wasatch days. I put it under severe, but oh well.
Yeah.
I'll
So
have to
those
move
are
it.
those are the 5 most active
Yeah, these are the
segments.
5 segments. That's what I was trying to grapple with when you were reading, going, well, where the hell am I? Because I don't know Utah. And I know that San Diego Dan knows, and so does Kat, both of which are in chat right now.
Yeah.
So, all right. So,
it's gonna
the next one.
explain each of the segments in the next one.
All right. Share this one instead. All right.
The western region of the United States is well known for majestic mountains, dry deserts, and expansive vistas. Geologic forces have been at work here for millions of years, and earthquakes play an important part in shaping the landscape into what we love about the West today. In this video, we will take a closer look at how earthquake activity impacts the Intermountain West region, particularly urban areas near the Wasatch Fault.
Yeah, I think we've looked at this.
Although most earthquakes occur near plate boundaries, there is an area of increased earthquake activity within the interior of the North American plate, known as the Intermountain Seismic Belt. The belt extends 800 miles from Montana to Nevada and Arizona. The
Just
Wasatch
north of me.
Fault lies within the Intermountain Seismic Belt and is in the transition zone between the relatively thin and extending crust of the Basin and Range Province to the west and the thicker, more stable crust of the Rocky Mountains and Colorado Plateau to the east.
On the Colorado Plateau.
The 240-mile-long Wasatch Fault has the dubious distinction of being one of the longest and most active normal faults in the world. A normal fault results from crustal stretching and is characterized by predominantly vertical movement where the mountain block, Wasatch Range, moves upward relative to the downward moving valley block. Although no large earthquakes have occurred on the Wasatch Fault since pioneer settlement in Utah, the geologic record shows that numerous large surface faulting earthquakes have taken place on the Wasatch Fault over the past 10,000 years. The
valley
fault
falls,
is
the mountain
sectioned into
rise.
10 segments. The Malad
normal
City segment
fault.
in Idaho,
It's not
the
this,
Clarkston Mountain
this.
segment seen here crossing the Utah-Idaho border, the Collinston segment, the Brigham City segment, the Weber segment, the Salt Lake City segment, the Provo segment, the Nephi segment, the Levan segment, and finally the Fayette segment in central Utah. These 10 segments average 25 miles in length. Each segment can rupture independently and is a separate source of large earthquakes. Approximately 1.6 million people, about 80% of Utah's residents, live along the Wasatch Front, which coincides with the Wasatch Fault, the western base of the Wasatch Range. These cities and communities' close proximity to a large active fault contributes to the Wasatch Front's designation as having the greatest earthquake risk in the interior of the western United States. The largest earthquake expected along the Wasatch Fault is about a magnitude 7.5. The amount of fault movement that produces large earthquakes, magnitude
Which got
6.5 to
downgraded to a
7.5,
6.4.
is enough to rupture and offset the ground surface. The 5 central segments of the Wasatch Fault present the greatest risk for people living along the Wasatch Front: the Brigham City segment, the Weber segment, the Salt Lake City segment, Provo segment, and the Nephi segment. The composite recurrence interval, or how often a large earthquake has occurred on the central portion of the Wasatch Fault, is approximately once every 300 to 400 years. The 2 last large earthquakes happened about 500 years ago on the Weber and Nephi segments. This is why you may have heard earthquake experts or news reports say that the Wasatch Front is overdue for a large earthquake. For any individual segment of the central portion of the fault, the average recurrence interval is longer, about every 1,200 to 2,600 years. Let's continue our tour of the Salt Lake City segment, starting at the south end of the Salt Lake Valley. The southern extent of the Salt Lake City segment terminates at the Corner Canyon area near the city of Draper. As you follow the fault north, many signs of the past earthquake activity are visible to expert and novice alike. Typically, the fault is easily recognized as a steep, almost continuous escarpment along the base of the Wasatch Range. This escarpment, or fault scarp, forms when large earthquakes rupture and offset the ground surface. Prehistoric earthquakes on the Wasatch Fault have typically displaced the ground surface about 6 to 10 feet for 20 to 40 miles. Here at the mouth of Little Cottonwood Canyon, many earthquake features like scarps and grabens are visible. In May 2008, the G.K. Gilbert Geologic View Park was dedicated. This park at the intersection of Wasatch Boulevard and 9800 South highlights many of these features with interpretive signs and spectacular panoramic views.
It is beautiful. I drove
Multiple fault scarps cut across 16,000 to 18,000-year-old glacial moraines at the mouths of Little Cottonwood and Bells Canyons. Lower Bells Canyon Reservoir, now drained, was situated on land lowered between 2 fault scarps. This
Now
low
drained.
spot is called a graben. The fault scarps in this area are 100 to 130 feet high, indicating they were formed by as many as 7 to 10 large earthquakes in the past 18,000 years. Sand and gravel deposited as a delta into Lake Bonneville about 14,500 to 16,000 years ago by Little Cottonwood Creek are displaced by the Wasatch Fault. Now a water filtration plant sits on this ancient delta.
I wonder where
High
the
fault
Bonneville
scarps
is.
indicate
The-
several
which
large
is-
earthquakes have taken place here over the past 14,500 to 16,000 years. The other arrows show the fault zone branching into 3 strands in subdivisions adjacent to the Wasatch Boulevard in Salt Lake County. Visible scarps are not continuous along the fault. They disappear at segment boundaries and in areas where natural erosion, deposition, or construction has obscured them. In most places, the Wasatch Fault is at the base of the mountains. In other areas, the fault extends away from the mountains, such as in the Holiday area, where Highland Drive parallels part of the fault. In addition to ground shaking and surface fault rupture, earthquakes can generate other geologic hazards that include soil liquefaction, slope failure, and flooding. Not only are buildings, including homes, endangered by these hazards, but water tanks, dams, roads, bridges, railways, airports, and utility corridors carrying electricity, water, sewage, natural gas, petroleum, and telephone service are all at risk. Along the Wasatch Front, many of these structures and utility lines are located on or cross the Wasatch Fault. Although development, and in some cases unsafe development, has encroached on the Wasatch Fault, some areas have more compatible land uses with an active fault, such as tree farms, golf courses, and parks. For example, Fault Line Park, located at 400 South between 10th and 13th East in Salt Lake City, sits on the Wasatch Fault Scarp.
Because Utah has not experienced a large, damaging earthquake in the heavily urbanized Wasatch Front since the pioneers entered the area, many older, vulnerable buildings place people at risk. The state of Utah has retrofitted the state capitol building in a way that preserves this historic building and ensures the public safety and continuity of government in the event of a large earthquake. Improved building codes are in force statewide. Some older buildings have been strengthened, and steps are underway to upgrade schools and other critical facilities. Utah's Wasatch Front is a desirable place to live, but choosing to live here includes accepting earthquake risk. Earthquakes are part of the earth that we live on, so while we can't change the fault, we can learn to live with it. Natural hazards are present in all regions of the U.S. Therefore, it is prudent to be aware of what we can do to lessen the risk of damage and injury from natural disasters wherever we live. And awareness is the first step in risk reduction. For more information about earthquakes, how you can prepare for them and other geologic hazards in Utah, visit our website at geology.utah.gov or visit the Utah Department of Natural Resources bookstore to find other materials and information.
I love you too, Mom. Bye-bye. All right. That was a pretty good little deal.
Yeah,
Kind of give us a little information in there.
Yeah, because I wanted to find ones that were fairly short that basically explained everything.
Yeah. And
Now-
I had to find out where Lake Bonneville was, and I did.
Yeah.
It's on the map on the screen today. I didn't realize Great Salt Lake was part of it.
Yeah, because it was gigantic.
Yeah.
And talking about, there is an 1.5-hour video that's a bunch of geologists talking about if there was a big quake that caused Lake Bonneville to spill over.
Yeah, I think it's more
I
important
found that one when I was looking for the other stuff. But
right. I think it's more important to stay with what we're doing here, and yeah, at a later date that probably would work out.
yeah, like it'd be good play
No doubt.
other times.
Yeah. You know, which is kind of where we're at now. You know, and I think we've talked about the seriousness of the different segments of the Wasatch Fault. And now I suppose you want to go ahead and look at the large earthquakes in the area.
Yeah, it's like a storyboard. So you
Okay.
like slide down and then it says each one.
Okay, cool.
It doesn't take very
Share
long.
this
to
tab
go through.
instead. All right. As soon as I close, share this one. There you go. All righty. Scroll
And
through
it
the
showed
map
the
to learn about large earthquakes. Up here, Malid or Malid.
Yeah.
Malid.
So that's the one that's in Idaho.
Okay. Then
That's mine.
Ogden, then Salt Lake City, then Nephi. Yeah.
So
Malad.
it's showing it right from top to bottom. So when
Yeah.
you slide down, it'll give a little blurb on the side there.
Okay,
Like
Wasatch Fault is one of the longest and most active. We know about that already. Fault is divided into 10 segments. Wow. Malad, Clarkston, Collinston, Brigham, Weber, Salt Lake, Provo, Nephi. God bless America. Levan, Levan, and Fayette.
Yep.
All right. That darn button is down there. The fault divided into 10 segments, averaging 25 miles each length. Each segment can move independently, as well as we've learned that they can move together. Move to the entire Wasatch Fault all at once is extremely unlikely. However, geologic investigations indicate that at least parts of an adjacent segment may sometimes move simultaneously, generating earthquakes up to 7.5. Yeah. Okay. They dig trenches, right? Like this thing.
Yeah, so
And
it explains the stuff that was in the video, basically.
right. Which is pretty cool. They get a cross section, and we've seen videos of this. We've studied these things. The large earthquakes magnitude 6.5 and greater leave geologic record of their occurrences in form of diagnostic sedimentary deposits. These deposits can often be dated to determine earthquake timing. Yeah. Okay. Central part of Wasatch Fault has been most active. At least 23 large earthquakes have occurred in the past 6,000 years. Central part. Okay. This is the central part of it, which is all the areas we just talked about, other than that very top one. And Fayette on the bottom. So 1, 2, 3, 4, 5, 6, 7, 8. Yeah. The top one and the very bottom one. So the average time between earthquakes about 300 years. 5,900 years ago, that popped. I want to say the Weber segment, wasn't that the one that popped in 2019? Was it?
Well, we're going to read the study about that, and it'll tell you.
Okay. All right, buddy. 5,600 years is the northern one. 5,300 years is this one. It's right in this area, Salt Lake segment. 4,700 years ago. 4,500 years ago. What was happening around this time in the continental U.S.? 4,500 years ago to 6,000 years ago. What was going on?
Yeah.
Well, we learned that that was millions of years, so it wasn't the Grand Canyon starting up. This is all really, really, really recent after the melting of the snow began. And I think when did Lake Bonneville do its thing? I don't know the date on that one. Was that 17? Yeah, I don't know the date on that. I'd be interested. I'm interested in finding out those kind of dates. See, we're drilled down pretty deep, and I need to come off the map and see what's going on all the way around it, seeing why these earthquakes are happening. But we're drilled in pretty deep right now. 3,100 years ago, 2,400 years ago, Brigham City. Huh? Okay, that's pretty recent. 22. That's a pretty big one right there, boy. 2,000 years ago, Nephi. 15, Provo. Wow. 13, Salt Lake. 1,200. 1,100. People all living in the U.S. around here. 1,000 years ago. It's about the time that Grand Canyon had its last volcanic movement, about 1,000 years ago. Might be related. Might not be.
Because this is all from trenches and fault studies.
Yeah. 600 years ago. They didn't see anything in the Salt Lake, but both of these segments go. That's kind of odd. They just didn't find evidence of it on the Salt Lake. Wow. 200 years ago, Nephi.
Because I thought it was cool how they did this one storyboard.
Yeah. Storyboard's pretty cool. I like it. I like how it's done. Indicates 18% probability, 1 in 5 chance a large earthquake occurred within the Wasatch in the next 50 years. You want to see a full technical report? I can do that. Let me see. Is it a PDF? Yeah, I'm going to download this one. Pardon me while I do a little homework. Excuse me. Boy, it takes a minute. It takes a minute. Oh, well, get back to it. Earthquake, be ready. All right. Well, I guess that's it on this one.
So it's giving you like the history of each segment when the last quake was on it. So
Right.
Pretty good.
Yeah. I'm gonna go desktop, Utah. There we go. All right. So we're to Salt Lake's 2020 now.
Yeah.
You want to talk about that earthquake? Go ahead.
Yeah, we're just going to read the first part of it because I have the main study on it as the next link because they found out more stuff since that one happened. Yeah, so I'm just going to read the first part. 2020 Salt Lake City earthquake. They also call it Magna earthquake too. At 7:09 a.m. Mountain Daylight Time on March 18, 2020, a 5.7 magnitude earthquake hit Salt Lake City, Utah, United States, with an epicenter 6 kilometers northeast of Magna, Utah, beneath the site of the planned Utah Inland Port. It was the first major earthquake to occur within the Salt Lake Valley since the city was founded. The state's strongest earthquake since the 1992 St. George earthquake, and the first earthquake of comparable magnitude to occur near Salt Lake City since 1962, when a magnitude 5.0 earthquake struck a similar location in Magna. So it had a 5 there before.
Right.
62.
I think also the lake has been receding quite dramatically. From what I gathered, I'll defer to Kitty out there. What's the status of the Salt Lake, the Great Salt Lake? I know it's receding pretty dramatically, but are they trying to save it, or is there a way to save it? I don't know. But I'm interested in that. Salt Lake City lies between the boundary of the Basin Range province. Major active zone is the normal Wasatch Fault that throws down to the west. The footwall up-thrown part is formed by the Wasatch Range, which is part of the Great Basin Lion, and the hanging wall, down-thrown part, at one time filled by Lake Bonneville, with the Great Salt Lake forming the largest remnant. The fault zone is broken up in 6 segments. Well, we know more than that. To appear,
depends on when they wrote this wiki.
Yeah. Usually they're pretty good. Indicate that 19 surface eruption earthquakes have occurred since 6,000 years ago.
Now it's 23. That's what
Mm-hmm.
Storyboard.
Earthquakes, focal mechanism, and depth were both consistent with displacement in the Wasatch Fault system at depth. Significant shaking was felt downtown Salt Lake. The earthquake was reportedly felt as far away as Wyoming and southern Idaho, which Wyoming's
so
not
it
that far.
went up the inner seismic belt. So that's interesting.
Okay. Yeah, I mean Wyoming's close. Like, it's from Salt Lake. When I was there, it's like from here to there. It's not very far. Seemed like an hour, 2 hours, I think, from there to there. The fault zone broken up into 6. Okay, we already talked about. The most distant report shaken earthquake heard Cokeville, Wyoming. All right, yeah, that's right where I was telling you. Over 110 miles away. Yeah, 2 hours. According to USGS, at least 26,000 people reported feeling in the earthquake. 50 aftershocks, and 4.6 was the largest. 4.2 happened a couple of days later. We reported on all of these, so you'll have to find which I don't have them online. Yeah.
Yeah, so it talks about the damage and stuff.
Right. Well, we don't need to deal with that. Powder outages, pandemic, blah, blah, blah. All right. Next, The next,
The next one is the big study they did as a result
Okay.
of it.
all right. The seismic record of this same earthquake. Although the Wasatch Fault is currently known to have high seismic hazards, motion along the bounding faults, new seismic data reveals the fault folded 13 to 30,000 year old Lake Bonneville strata beneath Salt Lake City. Coupled with the previous excavations, trench boreholes, and other geologic and geophysical observations, we conclude that the zone of latest Pleistocene and Holocene faulting and folding kinematically links the East Bench and Warm Springs faults through a 3-kilometer wide relay structure and transfer zone. We characterize faults beneath downtown Salt Lake City as active. These faults may displace and or deform the ground surface during the earthquake. Though the offset but link faults, our observations support thoroughgoing rupture across faults of the Wasatch Fault Zone and an elevation risk of earthquake inducing building damage. So basically they're saying, dude, it's going to do what it's going to do. Right.
Yeah.
Their study was in this area, and that's where the big earthquake happened, if I remember correctly. And we were wondering about why there. And in 2020, I think we know what was happening in 2019. And this quake, I'm not sure when it happened. And oh my God, big quakes everywhere. Into Utah, when did it happen?
It was right before Idaho, I think.
Yeah.
Gotta look back on the other one to see what the date was. Yeah,
I'm trying to get there too. Hey, I don't know why we're stuck.
I think it was right before, if I remember right, or right after. March 18th, it says.
March 18. Okay. So,
Yeah.
As you were looking at this,
I forget when the Idaho one was.
well, we'll get to the Idaho because I'm going to
Idaho
go back on you.
6.5. Well, we will when
I'm going to
do
go
the-
back to 2019 actually. So,
Yeah.
And in 2019, this is a list of earthquakes along our North American Cordillera, and the effects from the south all the way up to the north, where we are, along the west. And this is primarily in the center west portion of the United States. And this is not along the coast. So we're looking for events to happen. Canuck and I both have an idea that in Peru, we look for a quake that happens on the interior side quite a bit, away from the coast of Peru, for something to happen interiorly in the United States. And that's only because of what we're going to learn about in the next few rabbit holes when we talk about the American Cordilleras, from Alaska down to the Antarctic. And why Wasatch is important is because there's a lot of people that live there. Also, there's a record of earthquakes happening along this area. And it didn't happen out of the blue. They don't just happen. They're not random. And I think when somebody says they happen random, I think they're just mistaken. But in 2019, we're going to go back that far. We're going to list the biggest quakes along the American Cordillera from the south to the north. Brazil popped in January of 2019 with a 6.8. Interesting. Brazil. Peru popped with a 5. Argentina had a little 3.4. Chile, Coquimbo had a 6.7. And yeah, that's a pretty good sized quake. Peru, Ica, Peru, popped with a 5.7. And then Colombia came back with a 5.6. So what we're doing is we're bouncing in South America, Peru, Argentina, and Chile, back and forth with sizable earthquakes. In February, Chiapas, Mexico, the armpit of Mexico, had a 6.7. The DR popped with a 5.3. Dominican Republic along what? Both of those are along the plate of the Caribbean plate, the northern portion of it. And then Peru popped with a 5.5 again. Then the northern mid-Atlantic ridge came in with a 6.2. I would like to know exactly where in the northern, but it doesn't show. In 2019, that's interesting. Because I have a theory that the North America is pushed by the mid-Atlantic ridge, and I think it's already proven that. But interesting. Ecuador came in with a 7.5. That's significant. That's a big quake in Ecuador, which is on the northern portion of let me see, do I have a map up for you? I'll put a map up here for you so you can see where these are happening. Just for shits and giggles. And I'll put it on a terrain. Yeah. And put it over here for you. See if you can see that. Okay, yeah, you can see that. So northern Peru is up in is here. Here's Peru. Ecuador is this little country between Colombia and Peru. So it popped with a 7.5. Pretty serious. Slight damages. It's southeast of Polera. I don't know exactly where that is in a map. Oh, it's when you zoom in, it's like right out here. So it's behind the arc. Okay. In March, Peru had a 7.0. And Azangaro. I don't know where the hell Azangaro is, but Peru's in here. So Peru's already banging hard in March. And in when was the other one? Oh, in April had a 5.5. Right? And in January had a 5.7. Right? Yeah. And a 5.0. So super, super active. Peru with, several big quakes. In March, it had a 7. Bang. Then Puerto Rico popped with a 4.6. So we got Puerto Rico out here pumping with a 4.6. Pretty strong quake for that area. Argentina had a 5. Argentina's down here. And that was a shallow 13 kilometers, so not a very deep quake. Generally, they have a lot of deep quakes. I thought Bolivia was in. Isn't Bolivia down in South America too?
Yeah.
Yeah. Where the hell's Bolivia? Oh, right here. That's right. Yeah. Bolivia had a 6.3. Now we had a 7 here and a 6.3 here, and Argentina was banging as well. God bless America. I knew it was there. Colombia came in with a 6.1 up here again. Then Ecuador, 6.2. Already knowing that Ecuador has been banging around, right? So that's another Ecuadorian earthquake. Very significant. The Aleutian Islands came in at a 6.4. That's up in Alaska, of course. Sandwich Islands came in at a 6.5, which the American Cordillera comes down here, right to this, and then stops. Sandwich Islands is over here. It's almost like they used to be here, but moved over there. Oh, yeah. Yeah. Because they're acting up. And it's funny how that kind of does. United States, where the hell is this? Oh, Hawaii came in with a 5.3 in whatever month they were, April. And then South Georgia Sandwich had a 6 in that same month. And we're into May. Costa Rica has a 6. Costa Rica's right down in here. Right here in the central part. So we already know that the DR is popping, that Chiapas is popping, Colombia, Ecuador, right? And Bolivia, Peru, and all the other ones too. Already banging pretty good. So Nicaragua came in with a 5.9. After Costa Rica, Nicaragua bangs. Then the Aleutian Islands up in Alaska again hits with another 6. Then Peru bangs off with an 8.0. Navarro.
Wow.
Yeah.
That's crazy.
And
Which I already know because this is the lead up to Ridgecrest.
yes, the lead up. Yes. Then El Salvador again. What we're seeing, what we see, it started with Costa Rica. It went to Nicaragua, and now it's in Salvador, 6.6. Also, the big Peruvian 8. In June, Chile pops with a 6.4 off of Coquimbo. That's the central part, right? Yeah. Concepcion, Valparaiso. Coquimbo's down here, right? This state down here. 6.4. California, 5.6 off Petrolia. So we've got 6 power coming out of Costa Rica, Nicaragua, Salvador, then up here on the top up there. Comes in at 6. And we also have 6s up here in the Aleutians. So the whole portion all the way down to Colombia, Ecuador, all pushing 6s. In what month? This is in June. Kamchatka even continued with the 6s, 6.3 and a 6.4. Then Panama filled in the gap with a 6.2. And then in July, we all know what happened in July. Canada, BC, pops with a 6.2. So all the power moved way up here, right up to that section right there. 6.2 came in. Then Sears Valley, right down here, and just north of Ridgecrest, or at Ridgecrest, just north of Garlock, popped with a 6.4 on the 4th. And then Ridgecrest popped, the city right next to it, 7.1. And in Greece, there's Greece. Old famous Greece, 5.3 on the 19th. The Antarctica offshore, Bellini Islands had a 6 on the 25th. 3rd, sorry. Then in August, the East Pacific rise comes out of 6. East Pacific rise down here. Pops with a 6. Peru comes back with a 5.9. 4.9, sorry. 4.9. Then, interesting. Central part of the United States, Kansas, comes in at a 4.2. Interesting. Huh. Sandwich Islands come in at a 6.6 down the very bottom. Then Oregon comes back. Oregon. This is the largest offshore Oregon, 6.3. Right out here. Right off of Gold's Beach or whatever it was. Bandon. Right down in here. 6.3. So Kansas, 6.3. And then, or Oregon, California. Seemed like something's happening in the West.
Yeah, wait till you get to
Puerto Rico
25.
pops. Puerto Rico pops with a 6.0. Chile comes back way down the bottom of Chile, 6.1. And then Chile again, 6.7. And then October comes around. And nothing happened in our side. Then in November, Georgia Sandwich Islands pops with a 6.1. Chile comes in with a 6.1. Georgia or Sandwich Islands again, 6.3. Big power down the bottom. Mexico Chiapas pops with a 6.3. Then the Aleutian Islands had a 6.3. 6.3s are cheap. And there's Crete, Greece, 6.0. So in December, the Aleutian Islands came in with a 6. Chile came in with a 6. Vancouver Island popped with a 6. Vancouver Island popped with a 6. Argentina had a 6. Colombia had a 6. Vancouver Island had a 6.3. Man, did it pop. Vancouver Island just banging away.
Yeah, those are the 3 quakes I slept through when I was mad.
Yeah. and they just bang it away. And I remember a lot of that, but I was already planning to go live and make this channel at that time because of failure on the other part. Puerto Rico pops with a 5. So we have 1, 2, 3 big giant quakes in Canada. And that's in December. So that as we roll over to 2020 in the January, remember what's happening in North America, right? All that other craziness. Mexico, Oaxaca has a 6, 5.9. Puerto Rico has a 5.8. So Puerto Rico starts to bang. That's 2 big bangs down there, plus the DR, right?
Yeah.
And in Puerto Rico, again, 6.4. That's when I thought it was going to fall apart down there. I was keeping close eye. I still today think about Puerto Rico because they get all these little quakes, but boy, man, well, they can get some good ones. 5.2, so pretty significant. 3 big quakes, a 6.4, a 5.2, and a 5.9. All happened right there in Puerto Rico. We didn't know what was happening. Argentina came in with a 4.5. Then Oaxaca, 5.2. So the Caribbean plate was being banged on the northern section really hard. So something was reverberating out throughout the United States. We had Kansas, we had offshore Oregon, we had California, all banging, bang, 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 bang. And it was vibrating on top of this, the Caribbean plate. And down in the south, all hell was coming out. And all the way from its toenails down here, all the way up to the central part of Central America. Kansas, 4.5, banging again. Crazy. And this happened in January. So there's a double whammy in Kansas. Right? So we're into February. We have Sandwich Islands came in with a 6. And then in March, Baja California had a 5.5. So finally coming up into California again. Utah. Here we go, Utah. 5.7. So we have Kansas banging twice. We have Ridgecrest banging twice. Off the coast of Oregon, right? And then Salt Lake banging right there.
Yeah. And then Idaho was next.
Yeah, Idaho comes next. I'm waiting for it. Yeah. Then Greece is in there again, 5.7. I'm just cutting out.
I just wanted to point something out in here because I think the LPR limit. Well, I can list the quakes. So the 6.4 big one in Puerto Rico. Then you had the 2 in Kansas, which are on the limit. Then you had Salt Lake City, which is on the limit, and then you had Idaho. So there's your LPR limit going batshit crazy.
Yeah, the Olympic Walla Walla, the owl.
Yeah, because the owl comes right down and goes right pretty close to where the 6.5 was.
Right.
If you keep it on that same line that I have, it goes right on.
It goes right out to the Ascension Islands. Yeah.
Yeah.
And Ascension's had issues too, but I'm just not saying it. So Utah banged, and that's the one we're talking about. So we know what led up to Utah, right? All of North America was banging. The vibration on top of the Caribbean plate was banging. The big giant quake down here in Peru, which was already hitting, something was telling it to move. We had Ecuador banging off. We had Colombia banging all up and down the Central America. Oaxaca and Chiapas in Mexico were talking. And then the DR and Puerto Rico were saying, back and forth, right? And the Central East Pacific Rise comes in with a 6.1. Then, of course, the Kurils have the 7.5, but that's Idaho comes in right then. Right? Is that the same month?
Yep.
Sure is. The same freaking month as
Lake was right before Idaho, two
right,
weeks.
On the 31st and the 18th. Yep. So Idaho, 6.5. In some areas, 6.9 maybe. Yeah. Stanley, Idaho. And Stanley, Idaho hasn't stopped. It's still saying hello. And so we led up to what led up to it for at least 1 year back. And what we see is just observations. You got the mid-Atlantic. There's an event that happens out there in the mid-Atlantic that's coupled with all this stuff all across the United States, from Kansas to Idaho to Utah to Oregon to Los Angeles and on down to Mexico, all through Salvador, Nicaragua, Costa Rica, and it didn't say Panama. Yeah, it did. One Panama, Colombia, Ecuador.
I remember the Cayman Islands 7.7 was in there.
Right. That comes up. It comes up pretty soon. I know. Yeah. I was about to see if it was this year.
In 2020, and then also in 2020 you had the Oaxaca 7.4, and then within a day or two the Lone Pine 5.8.
Right. It still keeps going here. Yeah. So Baja comes in again at 5.5. And Utah comes in at a 5.7, right? And then we got the Greece one. And then Idaho pops with a 6.5. This is all, what, in March. Then in April, Colombia says hello with a 5.7. Honduras says a 6.1. Greenland, right, has a 4.6. That's interesting. In May, Puerto Rico has a 5.4. And of course, Crete is saying 6.5 over there, Greece. Yeah, it's a weird connection. I don't know what it is. Nevada. We forgot about Nevada. Yeah, just a couple months later, Nevada bangs off with a 6.5.
Yeah, the Monte Cristo thing.
Yeah.
It's all magic.
And in Baja, again, 6.1. And in Peru says a 6.1. Then in June, this is almost 1 year after Ridgecrest, by the way, that all this is happening. Chile says a 6.8. Peru has a 4.5. The Ascension Islands come in at a 6. The Ascension and Tristan to Kahuna. So that's out here. Right?
So Texas
that's along that limit.
Going crazy 2019, 2020. Mm-hmm. And if you go into 21, that's when La Soufriere was going nuts.
Correct.
All the other big quakes at Sand Point and our last 3/8.
And then Mexico happens here. Oaxaca comes in with a 7.4. And then California, right? Lone Pine, way up here north of Ridgecrest, pops with a 5.8.
Because I think that was June.
Yeah, June. And then I'm sorry. If you just draw the lines, you see the history here. So Puerto Rico then again comes back with a 5.3. So we know something's happening right here. Puerto Rico is banging, 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 right? We know that a lot of energy is traversing the Caribbean plate on the west. It's translating power from North America or South America through North America, up Mexico into the Gulf and in through California. Then it's spreading out to basically Vegas, Salt Lake, and Provo. And we have Vancouver gone off, right? Got Oregon gone off. So the western part of this area, this is our focus area, what we're trying to talk about. We talked tonight about the Wasatch Fault. Well, there was a quake that happened on it, but it didn't happen in a vacuum. It happened because there's something going on in the plate movement that reverberates through the whole entire American Cordillera, which is from Alaska up here, all these mountain buildings, all the way on mountain ranges, all the way down into Antarctica. That it reverberates, it vibrates all throughout. And yes, there is a push out of the mid-Atlantic up upon the North American plate, which also pushes on the Caribbean plate, which pushes on the Cocos and the Nazca and the Antarctic, and hence the Pacific plate. And watching this back and forth play from the Pacific plate to the North American plate, or our mid-Atlantic ridge from the East Pacific rise, this interplay back and forth, that's the chicken leg for me. Back and forth. You just see it. It's almost like a song, so to speak. As Puerto Rico pops in July of 5.3, and then what else? Chile comes in at a 5.9. Alaska has a big 7.8 and a 6.1. Sandpoint bangs off. Now
'Cause
that was
Texas
recorded
Lebanon
as an
went
8,
way
and they
up for
downgraded it.
3 years before Sand Point started.
Right.
basically.
And this is still we're still in 2020.
Because the first 2 quakes at Sand Point were in 2020, and then the
7.8,
8.2 was
6.1.
in the 8.2 was in 2021.
Right, the next
After
year.
La Soufriere blew up.
Right. Sandwich Islands come in at a 6.4 right after. And then Alaska, Sandpoint, again, the third quake, a 6.1. So we had a 7.8, a 6.1, and a 6.1 up in Alaska, all happening in July. We didn't know what was happening then. You know, Puerto Rico comes back with a 4.8. It's not stopping. Although it's less than a 6, it's not stopping. North Carolina comes on this side, 5.1. Strange place there's no plate boundaries for some of these earthquakes.
Yeah, and remember that was the year Iceland started and La Palma.
Yep.
2021.
Because Etna stopped. Etna was going off during this time. It stopped. And then Iceland. And then the Canary Islands.
Because 2021, the big eruptions were La Soufriere, La Palma, and Iceland.
Mm-hmm.
Magic.
Yeah.
You never guess what
and Etna.
that means.
Yeah. Costa Rica comes in at a 6.0. Brazil 4.6. Central Mid-Atlantic Ridge 6.5. Somewhere down here near what? Near the Caribbean plate, right? Puerto Rico's here banging off already. The Mid-Atlantic's going haywire. We see the Ascension Islands already telling us something's happening, right? And it's September. Chile says hello with a 6.8 and a 6.3 and a 6.5. Bang, 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 bang. Atacama. Right? And Coquimbo, which is a little bit north. Right? Comes at a 6.3. Then the Central Mid-Atlantic Ridge hits again. 6.7. Something's building. Chile pots with a 6.2. Whoops, sorry. Chile down here pots with a 6.2 in Tocopilla. Again, Central Mid-Atlantic Ridge, 6.9. Bang. Then Los Angeles pops with a 4.5 in South El Monte. So we still see activity in the West still moving. We still see activity along the Mid-Atlantic Ridge. And then South Africa has a 6.1 right along that same time period or lineament that's straight out that captures several of these quake locations from Vancouver all the way to this little island out here. Caligula, I call it. Kerguelen, yeah. In October, we see, I think North Africa was starting to see in Spain. Then Alaska, Sandpoint pots with a 7.6. Huge quake. Greece, the North Aegean had a 7.0. Not to be outdone, right?
Yeah.
And then Chile, 6.0. Massachusetts, 3.5.
Yeah, and that was right after La Palma started erupting.
Right. And everybody was afraid that La Palma was going to fall off into the ocean because it is splitting. And if it does fall off, yeah, the whole east coast of the United States is wiped out. There's no doubt. Yeah, 100-foot plus tsunami. Chile pots with a 6.1. Argentina 5.8. And Argentina 6.3. Relatively deep, 189. Is that last
No,
Chile?
because La Palma was 21.
At 6.4 is Alaska, the Aleutian Islands. So the Aleutian Islands have been always talking. The Bellini Islands, again, had a 6. Chile had a 6.1. Chile had a 6.0. Peru had a 5.6. Peru had a 5.7. Chile had a 6.7. And that concludes 2020. If you want to take a look at 21, we will, but I think we got away from Utah.
It's all leading into the 3/8 in
Yeah, okay. There
which
we go.
was the last time we had an 8.
Which is the last time. I'll start with January then. Alaska had a 6.1, the Aleutians. So up here, Aleutians banging away. Already Sandpoint had a 7 and several 6s. That's banging away. Argentina Juji has a 6.1 down in Argentina, northern Argentina. Argentina San Juan had a 6.4. It's a little bit central Argentina. The Andalusian earthquake swarm happened. Andalusia, Spain, 4.2. And the Shetland Islands, in that down here?
Antarctica,
Yeah.
South America.
Yeah. Right down here where the UK was going to war, right? 6.9. Crazy. February. The West Chile Rise, right through here, 6.7. So this is pushing hard. We're seeing activity down here. We're seeing activity out here after it's gone through South America. I still think that the Atlantic is pushing the hell out of everybody.
Well, and Iceland started erupting, I think, March 2021.
All right.
I think it was. Because it went Iceland, then La Soufriere, then La Palma.
Greece, region of 5.5. I'm only bringing that up because it's kind of funny how Greece is always doing something. Colombia had a 5.1. We're in March. Greece had a 6.3. Thessalonica. That's northern Greece. I'm bypassing the first 8 because it's in New Zealand down here. And there was actually 2 of them down there. Greece 5.8. Slew of 6s down here too. Peru pots 4.9. Guerrero, Mexico 5.3 or 5.7. Sorry. Western Macedonia 4. Okay, April. Sandwich Islands come in with a 6.6. Wow. Happy Eye was 6.5s. Wow. I don't remember when Happy Eye happened. Nothing's happening there. May. El Salvador has a 6. Panama has a 6. Chicxulub, Alaska has a 6.1. Then in June, San Juan, Argentina had a 4.8. The DR, Department of Congo, sorry. That's Africa. Peru, 5.9 offshore. Argentina, 4.6. July. Chile, Atacama is a 6. California, Smith Valley, 6.0. That's the Ridgecrest area. So Ridgecrest hit 3 times. Right? In this sequence, Panama, 6.1. Peru, 4.9. Panama, 6.7. Alaska, 8.2. Peru, 6.2. And that all happened in July. Then in August, I don't know the date on lawsuit free, but Sandwich Islands came in with a 7.5, 8.1, 6.7, 6.1, 6.0.
Lawsuit Frere was May, I think.
Andalusia again 4.6. Alaska Aleutians 6.9. Haiti 7.2. Sandwich Islands again 6.9, 6.1. 6.0, 6.6, 7.1. Honduras 5.2. And then that was all in August. And then September, Guerrero, Mexico had a 7. Acapulco. Argentina had a 6.2. Peru had a 4.6. Chile had a 6.4. Nicaragua had a 6.5. Alaska comes back with a 6.1 as Greece hits a 6. And that's 5.3. Argentina comes at 5.49. October, Sandwich Islands again 6.2. Argentina 5.0. Peru 5.7. Starting to mellow out, isn't it? Hawaii comes back with a 6.2, and Alaska comes back with a 6.9. Aftershock to the 8.2. And of course, Greece is saying 6.4. Argentina 5.4, and then as we get through November, Sandwich Islands come back with a 6. Nicaragua 6.3. I think there's an argument to be made that it goes all, and Peru comes back with a 7.5 way back in
I
November.
think they're going to get pretty soon to South Sandwich 8, I think.
We already had one. In December, Sandwich Islands had a 6. Chile had a 6.1. Peru had a 4.1. Chile had a 5.7.
I thought
6.0 Sandwich Islands.
when was the South Sandwich 8?
Hold on. 5.0 Salta, Argentina. California, Petrolia comes back with a 6.2. Well, Jalisco, Mexico, 6.0. Haiti, 4.4. And the bigger Sandwich Islands happened. What month was that? I thought July, maybe.
Well, Sand Point was July. I thought it was a different month.
I'm looking.
Because the last 3 8s were all in 2021.
Correct. There's so much happening this month.
And it was Kermit X. Sand
Yeah, I
Point.
bypassed those. Yeah,
Sandpoint and then South
Yeah.
Sandwich. Yep.
South Sandwich. was in. There's a 6.9 there. Haiti had the 7.2. Sandwich Islands had a 6.1. 8.1 in that same month, and that's August. All right. So Sandwich Islands happened in August, right along with Haiti 7.2.
So our last date then was August.
Yeah.
2020.
August 12th, if I remember right.
Let me show you. Our Alaskan was 29th of July, and then Sandwich Islands was the 12th. 7.5 and 8.1, 6.7, 6.1, 6.0. Then a 6.1
So now
on
we're,
the
so
13th.
now we're 2025. That's the last date. So that's a long.
Right. So, and if you couple, I don't know when Lhasa Free erupted.
I think it was May 2021. Iceland was March, and La Palma was right after the Iceland eruption finished, like the same day. So I remember looking that up and say, well, that's weird. As soon as Iceland stopped, La Palma blew.
Okay, series eruptions begin
in April, too.
April 9th of 2020. It's
Yeah, April. Okay,
and extrusion of lava on December 27th of 2020, culminated in explosive events between April 9th and the 22nd of 21. So lava began to flow on the 27th of December, but the real explosion happened on the 9th and the 22 of April. In that same month, in April.
And I think the original Iceland eruption started March, I think, that year. March 2021 at Gelding, whatever.
Yeah, the Loyalty Islands, remember that one had a 7.7 as well in that month. In February, I thought there was a mid-Atlantic that took place. Well, I'm looking for that. I mean, it depends on just how you read these things. You can be kind of subjective, and I admit I'm a little bit subjective because I see something and I'm trying to see if it's real or not. So I'm supposing it is and running with it, and then if it just pans out where it's not, hey, it's not. But the West Chile Rise had a 6.7, and I'm looking for the Atlantic. Thought there was an Atlantic one. I mean, there's a couple of them in 20. I wondered, did it take that long for it to pop up? Yeah, it probably did. Because already in April, May. So in the same month of April, around the world, New Zealand and Kermitics were banging a little bit. Georgia or the Sandwich Islands had a 6.6. And New Zealand's with the 6s, and plenty of them. Tonga Happy Eye was really going on. When did it explode in 23?
Yeah.
Okay. I started watching it back in 21 then. Wow. I didn't like what I was seeing. I said,
yeah, because it was having quake swarms before.
Yeah, I said if this thing gets any water down in that magma chamber, it's going to explode. That's what it did. Yeah, it came apart too. Yeah, pretty crazy about Oh, just by checking out the last few years. See, because we live today, our perspective is really kind of limited to happening right now, right? We have hindsight, which is good, but because we live in an environment, or we live in an age of microwave, is like instant food, instant everything, right? We don't understand that these geotectonics take time to reveal themselves, what's going on. And so we often, Canuck and myself and Luke, we often look past 1 year and forward 1 year, and to try to of an older quake, look a year ahead, a year or 2 years ahead, to try to see where the flow is happening. And like on your map here, if you just looked at Africa, you know what's happening. That East African rift is super banging. And I don't think I've ever seen it as popular as it is doing it right now. But that tells you something. What's going on?
Well, if we trace the Hansel Valley, Utah, 6.6 and 34, I already know what happened the previous years because we've already looked at them.
Sure. Go ahead.
So to say how that went, well, Colima had 8s and 7s and 32. Long Beach was 33. 34, you had a big quake in Nevada, Cedar Mountain, I think it's called.
Yeah.
In 34. And then that Utah quake was that 6.6, the same year, 34. Mm-hmm. So see, it's doing the same thing again.
Yeah, what would be happening down in South America and Central America at those same time periods?
Yeah, well, you'd have to go down and look.
And I don't think they had
30.
I don't think they had an ability to triangulate too much and be, really close to where the triangulation would be, because I think only major cities in the late 1800s even had a seismogram, right? I don't think it came around till, wait, did that come in the 1900s?
No, the first one in the States was Berkeley, I think, 1840 something, I think. I can't remember. I'd have to look it up again. They had one in California pretty early.
Right. Seismograph.
Yeah.
Earliest in the world. Chinese had something at 132. Wow.
Yeah, they had some other primitive seismometer. Because you have to look by like each place.
Right. Yeah, early history. If you want to know that, I've got an article here for you, so I'll post that in Twitch for those who want to have that. Kat says 1800 Scotland. I just looked at chat. That's the only reason.
Yeah, I'm pretty sure the Berkeley one was like 1840s or something.
Yeah.
The first one in California. First seismo.
Carl Richter, 1930s. So, Southern California using relatively high frequency data from nearby seismograph stations. The logarithmic earthquake magnitude scale developed by Charles Richter in 1930. See, most of these, they knew they were happening, but they couldn't triangulate it too well. So.
Well, yeah, the more seismos they had, then they could figure out exactly where the quake was.
Yeah, right. So again, the whole purpose for looking back at these older quakes and then looking, they had a quake here. Well, they had a quake there. Are they related? Well, we often see a flow of related quakes. Right now on the map, you see South America, Central America, and then you see California and you see Oregon. Right up the line. That's not unusual. You often see Fiji area banging hard, Vanuatu banging hard. You see the maritime continent, you see Philippines, and you see Indonesia. Then those are all these other ones are all along the plate boundaries. But sometimes they're in the central part of the world, right? And you can see Rick James had a little banger today too, looks like. So I call it Rick James. I know it's Ricky James or whatever. I call it Rick James. Easier. Right? Right there. Charles Gibb fracture zone. 4.9 northern mid-Atlantic ridge today. Happened at 2303 yesterday. So we're already near 48 hours past. See what happens on the West Coast. Or even up in Alaska, and it's kind of up in the north. We have to look at the Canadians, but I don't know. Are they still out to lunch?
Yeah, they're probably off till Monday.
Yeah, they're still out to lunch. So nothing to report.
They're off for Christmas break for like 3 weeks.
All right.
They follow the same schedule as Trudeau.
All right. Well, we'll touch on the hurricane fault and those others next time around.
Yeah.
So we're already.
Well, it runs into Arizona, so it's going to tie
Yeah.
into Arizona too, right?
Yeah, it's going to come
That's
down
why
into the area. But it's all wonderful. This is good stuff. I know we kind of lay the fun stuff up where we look up earthquakes, after the fact. That's kind of the fun stuff because
So we're just building up the whole thing to see what it was doing.
Yeah.
Now we only did 2020, but we could have done 34. We could have done a bunch of the others.
Sure. Yeah. Is there anything you want to put out there, Luke? You don't want to ask a question or something? Because I know you've been watching all night. So, what really piqued your interest? What stood out to you?
Well, you kind of see a repeating pattern time after time after time. And that's what piques my interest is you see the repeating pattern happen, To me, that's what piques my interest in it, Is everybody says, well, it's just random. No, it's like Canuck says, it's not. There's a pattern to it. And if you can pick up on it, it's fairly easy.
Right. I don't know if there's an ability to forecast, but there's an ability to say, hey, within the next short period of time, I'd be looking in these places of interest.
Exactly.
It's like you're not forecasting. Like there's they just want money and they want the notoriety and the fame. I think what we're trying to do is the scientific method. It's hard to do because there's no really strong controls that we can create a scientific method paper on the supposition that earthquakes aren't random, that they follow patterns, and that depending on the different, we may not even know all the factors that create the problems, that create the earthquakes. To me, I think earthquakes are telling us of what's going on inside of our planet, not the other way around. You got a bruise and then you have a bump, right? Well, which came first? Right? So something bruised you, then the bump came out, right? You can see it. So it's kind of like that. You get a knot on your head, get hit first. It's not the knot, then the hit. So there's something going on. And I think that's my quest. What's that something. What is the world trying to tell us?
Well, this really now is quite forensics. You're trying to figure out where it came from, how it got to that spot, which I don't think they even have a word for that yet, because paleoseismology is the history of a certain fault.
Right.
But
Paleoseismology.
this is like figuring out how it's working worldwide for it to get to a certain place, which I think they can see now with the satellites.
Well, they can see the effects of the quakes. They can see that there's a pattern that persists because the quakes have happened along an area called a fault, and each fault moves. Tropical Capricorn.
Well, the new stuff says that Landsat 9 can see. They call them magnetic lineaments.
Yeah, that would be bitching if we can get access to that, eh?
In the new study since 2022, since it was launched, because it has an advanced magnetometer device, so they can see all this stuff. That's what they call them in the new studies, and I just found that from looking at Africa lineaments.
Right.
Since 2022, because I started looking up lineaments recently in Africa, and they say now they can see them, and in the studies they call them magnetic lineaments, and they say they're connecting across the Atlantic to everywhere in the studies. Like when they identify one they can see how it connects in Africa, but then they say, oh, it's coming off and it's going across through this fracture zone, it's going to South America.
Right.
And this is like in the new studies from 22.
Well, what's interesting about when you first introduced lineaments, you really didn't have a definition. You've read a lot of papers, Canuck, and you were talking about.
Well, I could see what it was doing.
Sure.
I just didn't know how to explain it.
Yeah.
Like I didn't know anything about Walker Lane until Ridgecrest happened.
Right.
And then I said, well,
that's when
the expert on it says it goes Haida to Gulf of California. But then when I read the neotectonics people, they say, when you find one, you just extend it by how it trends.
Right.
So now because of that, I think Walker Lane goes all the way from North Alaska to South Sandwich.
I think Walker Lane may be the American Cordillera.
Well, it could be the lineament that's moved everything northwest from when it was Pangea. I don't know. Like it would be different faults.
Well, I think in my mind, I think the Atlantic is what pushed it all apart. Whatever made the Atlantic rift happen, it separated Siberia. It separated all of it.
Atlantic is just pushing stuff west and east.
Right. It's separated us for why.
Yeah. It wasn't always
what's
there.
the impetus? What's the
just
impetus?
like the Pacific wasn't always there.
And in some ways, the Pacific came out of it, right?
To make a spreading ridge.
Yeah. Or all the other plates anyway came out of it.
Or there was some other north-south massive spreading ridge that was moving everything north-south back a long time ago.
Or 300 million years ago, we got nailed by a big giant something.
Yeah.
And when it did that, it broke up everything. It made everything
all the
start.
different names of the oceans before, so you have to find a fault that goes along.
Well, it depends on what nation you're in too, right? What they're going to call the plates. Canadians call it one thing, Americans call it another. The French say it's something else. Then the English call it something else. Like, please, all this is just to confuse us all. You need
back then, still everything.
You need a spreadsheet with all the different names, right?
So you're going to need all sorts of different plates, moving stuff, and different faults.
Right. Oh, interesting, bud. Is there anything else you want to close up with here, buddy? We're 2 hours and 14 already, plus the 45 we had prior.
That's another wild one.
Sure.
No, I can't think anything else. Right. We just haven't set up to go off the hurricane call into Arizona.
Yeah, we're set up to do St. George and Hurricane Fault. What day? Or Wednesday. So, yeah, we'll see what we do with that one. we have a lot more to do. All right. Thanks, everybody. Thank you, Canuck. Thank you, Luke. Peace out. Love y'all.
Be
Good
good.
night.
Good night.
Man, wonder how many of these things I got open. Just me now. Good night, everybody. Remember, don't get none on you.